Heavy transport inbound. Wait, we have an incoming projectile. Brake right.
Brace for impact! Mayday! Mayday! We are hitting the water!
The giant falls. Silence returns to the deep as the Iron Bird finds its final resting place.
2 years have passed. What was once a machine of war is now a foundation for life.
The ocean doesn't see a wreck, it sees a reef, a new home for the giants of the sea.
Even the smallest residents find shelter here. Nature's reclamation is complete.
A thriving ecosystem born from tragedy. This is the power of the ocean's resilience. Clearing the cockpit view, we need a clean surface for the primary attachment points.
Strap 2 is through the rear frame. Ensure there's no twisting in the line.
Shackle locked. That's the forward mount secured. We're ready for the surface link.
All 4 points are green. Moving to the safety zone. Surface, you are clear to take up the slack.
Holding hover at 50 feet. Rotor wash is heavy. Commencing the lift sequence now.
Winch is active. Cable is descending. We have visual on the marker buoy. Steady as she goes.
Tension confirmed. The airframe is holding. We have movement on the seabed.
Rigging is secure. She's coming up. Great job, team. Let's head for the surface.
Look at that. Decades of trapped air finally breaking free. She's light on the lines now.
The tension is holding. The crane is doing its job. Steady as she goes.
Coupling engaged. Initiating the secondary lift support. We have a green light on the seal.
She's off the bottom. Look at that silt cloud. We're clear of the suction.
Surface contact. There she is. After 30 years, she's finally seeing the sun again.
Transporting the asset to the mainland. The rigging is holding steady despite the wind.
Look at that corrosion. It's a miracle the struts held. This is precision engineering at its limit.
Easy now, bring her down. Welcome home, old girl. Mission accomplished, team.
Let's see what's hiding under 40 years of desert dust. Power it up!
Every one of these holes tells a story. We're cleaning away the grime to reveal the history.
The landing gear is caked in mud. We need to get every inch clean before the inspection. Easy on the cockpit glass, don't want to scratch it. Teamwork makes the dream work.
The whole team is on deck. This restoration is the biggest project we've ever taken on.
We're flushing out years of debris from the engines. Nothing stays hidden today.
There she is, 69150Y. A veteran of the skies, finally getting the care she deserves.
She's clean and ready for the real work to begin. Great job, team. Let's get to work on the restoration. All right, let's start with the hydraulic manifold.
Check the pressure settings on the tablet first. Schematic says 40 foot-pounds for this valve.
Ready? Perfect, that's locked in.
Main rotor bolt needs 250 foot-pounds.
This is a critical stress point.
Applying torque. Now.
Logged. Lower seam rivets going in. Pattern looks perfect on the scan. Keep it steady.
Masking is the most important part. Every sensor and window needs to be sealed tight before the primer hits.
First coat of primer going on. Even strokes, keep the overlap consistent.
She's starting to look new again.
Look at that coverage. That's the secret to a long-lasting finish, perfect preparation, and a steady hand.
Look at her now, from a rusted relic to a masterpiece. Great work, everyone. Phase 2 is officially a success.
Systems are green across the board. Let's move to the next phase of the inspection. Double check that terminal against the master schematic.
Perfect match. Logging the new component into the maintenance database now.
Scanning for structural integrity. The laser mapping is picking up every micro detail.
Pressure check on the forward landing gear.
Holding steady at 150 psi.
Intake manifold is clear and secured.
Found a hairline fracture right above the repair patch.
Confirmed. It matches the stress analysis from the last flight log.
Verify the flushness of this access panel.
Alignment is within tolerance. Logging it.
Hydraulic lines show 0 leakage. Rotor lock pin is out.
Understood. Forward stabilizer cover is clear and stowed.
Ready for the next blade rotation.
Final checks on the rotor assembly. We're almost ready for the ground run.
Applying the final coat of corrosion-resistant paint. This layer is vital for the aircraft's longevity.
Precision is key here. We need an even thickness across the entire surface to prevent weight imbalances.
From primer to finish, every step is documented. This bird is going to look brand new.
Does this diagram show the new ground wire routing?
Exactly. We need to ensure it perfectly matches the latest service bulletin for safety.
Look at this. This bundle here is definitely compromised. There's visible fraying.
I see it. Agreed. I've already applied the yellow tag for immediate replacement.
Can you hand me the crimping tool? Here you go.
Let's make sure this connection is rock solid before we seal the bay.
The complexity of the Chinook's electrical system is staggering. Thousands of wires, all perfectly routed.
Final inspection of the electrical bay. Everything is secure and ready for the next phase.
Avionics check in progress. Systems are coming online and looking stable.
Team, let's keep the pace. We're on schedule for the final inspection phase.
Station 4, confirm voltage reading for the primary bus.
Reading 12.5 volts, steady. The system check is officially green.
Exterior panel is secured and locked.
Confirmed on the digital manifest.
We are good to go on this section.
Avionics check is complete. All flight parameters are nominal and within spec.
Excellent work. Let's sign off on the final inspection and prep for ground runs.
Great job today, everyone. This bird is ready to fly. Let's clear the deck.
Keep the strokes even. We need a perfect seal against the salt air.
The coat is perfect. She looks brand new under these lights.
Rotor RPM is steady. All vibration sensors are reading green. We are good to proceed.
Verify the ground wire routing against the updated service bulletin. It has to be exact. Alignment is perfect. Let's run the rivet gun on the lower seam first.
Test point 304 is reading a steady 12.5 volts.
The system check is green.
Panel secure. Hatch is locked and confirmed on the digital manifest. We're good to go on this section.
Avionics are nominal, and the structural integrity is 100%. Sign off on the final inspection. She's ready to fly.
According to the updated schematic, this ground wire needs to be routed exactly through this bracket. Check the tension. Continuity check on the main bus. We need a steady 24 volts here.
Watch the meter.
Final systems integration is underway. All teams, report status on your sectors. We're on the home stretch.
powering up the primary avionics suite.
Look at that. Every single indicator is green. She's alive.
Hydraulic pressure on the forward strut is holding steady at 3,000 psi. Log that, and let's move to the rear assembly.
The structural reinforcement is perfect. Those rivets are seated exactly to spec. This section is stronger than the day it left the factory.
Right. Testing flight control surfaces. Cyclic response is smooth and immediate. All linkages are clear and calibrated.
2 years of hard work, and she's finally back. Mission accomplished, team.
She's ready for her first flight.
Pins out, stabilizer cover is clear. Moving to the next blade. Everything looks perfectly aligned.
Applying the final coat of olive drab. She's starting to look like a soldier again. The coverage is perfect.
Keep the spray even. We need a perfect finish to protect against corrosion. Watch your overlap on the seams.
Tail section is almost done. The paint is bonding perfectly. This specialized coating will last for decades.
Ground wires are routed.
Cross-referencing with the latest service bulletin now.
Everything matches the schematic.
Found the fault. This bundle is definitely compromised. Tagging it for immediate replacement. We can't take any risks with the flight controls.
Connection is solid. Let's get this sealed up before the humidity shifts. Multimeter readings are perfect.
Systems are green across the board. Avionics check complete. She's officially alive.
Great work, everyone.
The forward transmission casing is completely compromised. We're going to need the heavy lift gear to swap this section out safely.
The schematic shows this bracket must be perfectly flush.
Got it.
Let's secure the lower seam with the rivet gun first to ensure alignment.
Did you verify the pressure setting on the schematic?
Yes, it's exactly 40 foot-pounds.
Perfect, there's the click.
We need a full 250 foot-pounds on this main attachment bolt. It's a high fatigue area.
Roger that.
Applying torque now, watch the gauge.
All right, this harness looks good. Moving quickly to the next section before the wrench starts up again.
Checking test point 304, confirming voltage now. It's reading a steady 12.5 volts.
Copy that. System check is green, we're good to proceed.
A sharp, clear beep from the multimeter confirms a successful continuity test on the main power bus.
Access panel is fully secured. I've confirmed it on the digital manifest. We are officially good to go for the next phase. Great job. Checking test point 304 now.
Can you confirm the expected voltage on the schematic?
I've got a steady reading of 12.5 volts. The circuit is holding perfectly.
Diagnostic complete. All systems are reporting green. We are ready for the next phase.
Main panel is now secure. Let's move down and check the hydraulic pressure on the forward landing gear.
All cockpit indicators are within normal parameters. The intake manifold check is officially clear.
I noticed a tiny hairline fracture just above that new patch.
We should probably log it for the next inspection cycle.
Let's do one final check on the alignment of this main fuselage panel before we sign off.
Rotor lock pin has been removed. The forward stabilizer cover is clear. She's officially ready for flight. The rust penetration here goes deep into the structural frame.
I see it. And the damage to the rotor system is critical. We'll need a full teardown.
I've logged the serial number and the corrosion pattern for the forward rotor. It's worse than the initial report suggested.
The forward transmission casing is completely compromised by stress fractures.
Agreed. We'll need the heavy lift gear to pull this section for off-site repair.
Starting the surface prep on the engine housing. We need to get down to clean metal before we can assess the structural integrity.
According to the technical diagram here, this mounting bracket needs to be perfectly flush with the airframe.
Got it. I'll adjust the shim now.
Did you double check the schematic for the hydraulic pressure setting?
Yes, it specifies 40 foot-pounds.
There, the torque wrench clicked. It's set.
We need exactly 250 foot-pounds on the main attachment bolt, right where the fatigue stress is highest.
Roger that. Applying torque now. Log it as completed once I hit the mark.
Test point 304, confirm the bus voltage.
Reading 12.5 volts, steady and within spec.
Copy that. The primary electrical system check is green.
Circuit 842 is showing a steady 12 volts. We're good to go on this bus. Panel is locked and secured. I'm updating the digital manifest for the landing gear assembly now. All avionics systems are nominal. The flight computer is ready for the final boot up sequence.
The hangar is a hive of activity today as we enter the final phase of this massive restoration project.
Andy.
Give it a good polish. We want her to shine like new for the official rollout tomorrow.
Yeah.
Applying the final protective coat. Be careful with the overspray near the external sensors.
Rotor head assembly inspection is complete. Everything is torqued exactly to the manufacturer's specs.
Final inspection.
Final walk around is complete. She looks like she just rolled off the assembly line for the first time.
Let's verify the continuity on the main power bus against the 24-volt schematic. We can't afford a short circuit here.
Stripping away decades of salt and corrosion to find the solid airframe beneath. She's still strong under all that rust.
Applying the signature olive drab. This specialized coating protects against the elements and provides a low observable finish.
Every stencil and marking is applied with absolute precision, honoring the aircraft's original service history and identity.
Steady now, lowering the T-55 engine into position.
Watch those mounting bolts. We only have a 1/4 inch of clearance.
The new avionics suite is communicating perfectly.
All flight control sensors are reporting nominal values across the board.
Rotor head looks solid.
Inspecting the lead lag dampers and pitch links, everything is torqued to exact specifications. She's ready for ground runs.
Initiating the full system boot up. From a wreck on the ocean floor to a fully modernized digital cockpit. It's a miracle.
Stripping back the decay. We need a clean surface for the structural patches.
Every inch of this airframe has to be inspected and prepped. No room for error.
This section took a lot of damage. We're grinding it down to the base metal to ensure a perfect bond.
The structural integrity is being restored piece by piece. It's starting to look like an aircraft again.
This puncture is right near a primary load-bearing rib.
Right.
We'll need a custom-formed patch for this one.
The technical manual specifies this bracket must be perfectly flush. Aerodynamics are key. Understood, aligning it now.
Good. Let's
Double check the pressure specs on the schematic before we seal it.
confirmed 40 foot-pounds. That's the click we were looking for. Perfect seal.
This main attachment bolt takes the brunt of the fatigue stress. It needs exactly 250 foot-pounds.
Copy that. Applying torque, reach the limit, log it in the system.
This diagram shows the ground wire routing. This bracket needs to be perfectly flush. Got it. I'll align it now.
Look at this bundle here. It's definitely compromised.
Agreed. I've already logged it and applied the yellow tag for replacement. Pass me the crimping tool, please.
Here you go. Let's ensure this connection is rock solid before we seal the casing.
We are looking at the main wiring bundle near station BG3. A common failure point if moisture gets past the insulation.
Checking test point 304, confirm the voltage reading.
It's holding steady at 12.5 volts. System is stable.
All systems are go. The full diagnostic check is green across the board.
This panel is secured.
Confirmed on the digital manifest. We are good to go here.
Avionics check is complete. Every parameter is nominal. Excellent work. Let's sign off on the final inspection report.
The torque check is complete. This entire section is now solid and secure.
I'm routing the primary bus now. All connections are verified and secure.
Look at the starboard rotor alignment. It's showing a slight deviation.
Yeah, I see it. Looks like a quick fix on the linkage.
I'm stripping away the surface oxidation. We're almost down to the clean structural metal.
The patch is perfectly aligned. It's ready for the rivet team to take over.
Take a look at the wear on these bearings.
They're still well within the safety tolerance.
The systeming is currently in progress. All avionics modules are responding correctly.
We are clear for transport. Let's move this bird over to the paint booth.
According to this diagram, the ground wire routing should be here.
Got it. Let's double check that it matches the latest service bulletin updates.
Okay, connection confirmed. Moving to the next resistor.
Panel secured.
Confirmed on the digital manifest. Good to go.
Ground control checking test point 304. Confirming voltage now, reading 12.5 volts, perfectly steady. Copy that. All systems are green and nominal.
We have to verify the sensor calibration on the main bus.
Run the diagnostic sequence twice, make sure it clears.
Already prepped the interface check, should be quick.
Resetting auxiliary circuits. Stand by for power fluctuation. Main systems are now online.
Let's get a reading on the forward gear pressure.
Pressure is holding steady. Everything looks solid from this angle. The full avionics check is complete and every parameter is nominal.
Excellent work. Go ahead and sign off on the final inspection report.
According to the latest schematic, this diagram shows the precise ground wire routing for the main avionics bus.
Understood. I'll cross-reference every connection to ensure it matches the updated service bulletin exactly.
I've cross-referenced the schematic. This mounting bracket must be perfectly flush with the frame for proper alignment.
Obvious.
Have you verified the specific pressure rating for this hydraulic line in the technical manual?
Yes, the schematic confirms it.
The specifications require exactly 250 foot-pounds of torque on this primary attachment bolt to handle the fatigue stress.
Securing the patch panel now. The rivets are seating perfectly, restoring the structural integrity of the fuselage.
The restoration is a massive undertaking, requiring dozens of specialists working in perfect harmony to bring this giant back to life.
Probing test point 304 now.
Please confirm if the voltage reading is within the nominal range. Systematically checking each circuit breaker. All systems are coming online without any faults detected. Avionics check is complete and all parameters are nominal. Excellent work, team. Let's sign off on the final inspection and prepare for flight testing.
Let's start the exterior inspection. Mark, focus on the fuselage joints while I pull up the checklist.
Checking the digital checklist. Everything looks good so far. No signs of surface fatigue.
Wait, let me double check that serial number on the tablet. We need to be 100% sure.
The whole fleet is undergoing maintenance today. It's a busy shift, but we can't rush the details. There, see that smudge? Make sure it's just dirt and not a hairline crack in the panel. Confirmed, it's just surface grime. Logging it as cleaned and inspected.
Good catch.
Hey, James, heading to the engine bay?
Yeah, I'll be there in 10 to help with the torque tests.
Safety first. Every inch of these birds must be perfect before they fly again. That's our mission.
Checking test point 304. I need a steady voltage reading here.
Got it. 12.5 volts, rock steady. That circuit is live and healthy.
According to the latest schematic, the ground wire should route through this bracket right here.
Copy that. Double checking the torque specs against the new service bulletin now.
It takes a small army to keep these giants in the air. Every bolt, every wire, every system must be perfect.
Pass me the heavy-duty crimper. This connection needs to be rock solid.
Connection is secure. Now, checking the pressure on the rear mains. Everything needs to be within spec. Avionics are green across the board. All systems nominal. Excellent work, team. Let's sign off on the final inspection and get her ready for flight.
Starting the rivet sequence on the lower fuselage seam. Keep the pressure steady to ensure a flush finish across the entire joint.
Schematic check. What's the spec for these hydraulic couplings?
It's exactly 40 foot-pounds.
Torquing them down now to prevent any leaks during ground runs.
We need a full 250 foot-pounds on this main attachment bolt. This is a critical high stress point, so precision is everything for structural integrity.
Moving to the side panel. Aligning the rivets perfectly with the internal frame. Ready for the next sequence.
Hangar is clear and prepped, initiating the final spray cycle. We're applying the military-grade olive drab finish across the entire airframe today.
Maintain a steady 50% overlap on every pass. We need a perfectly uniform coat to meet the infrared reflective requirements.
Focusing on the upper rotor housing and engine cowlings now. Ensure the paint reaches every recessed area for maximum corrosion protection.
Final paint inspection complete. The finish is flawless and all serial numbers are perfectly legible. She looks like she just rolled off the assembly line.
This corrosion has eaten right through the aluminum skin.
We'll need to replace the entire panel to maintain structural integrity.
The forward transmission housing shows severe stress fractures. It's a total loss, and we'll have to source a replacement from the depot and bring in the heavy lift gear.
A cascade of brilliant orange sparks erupts as the grinder bites into the heavy steel joint.
The rapid-fire staccato of the rivet gun signals the structural rebirth of the aircraft.
The technical manual specifies a flush fit for this internal bracket. Even a millimeter of gap could kill vibration issues later.
Got it. I'll adjust the alignment before we secure it. Starting the riveting process on the lower seam. We'll work our way up to ensure the patch is perfectly tensioned against the frame.
Double check the pressure specs on that line.
Confirmed, 40 foot-pounds is the target. There, perfect seal achieved.
This bolt takes the most stress, so 250 foot-pounds is critical.
Understood. Applying the load now and locked. Log that for the safety report.
Alignment looks spot on. Let's secure the rest of this panel and move to the tail section.
The entire fleet is coming along nicely. We're actually ahead of the restoration timeline.
Keep the strokes steady. We want a uniform finish without any drips or runs.
The nose section is nearly finished. The coverage is excellent, and she's starting to look like new.
The schematic indicates the ground wire should route through this bracket.
Correct. Let's verify it against the latest service bulletin to be 100% sure.
Look at the insulation here. This whole bundle is compromised.
I see it. I've already tagged it for immediate replacement. We can't take any risks.
Hand me the crimping tool, please. I want to double check this terminal.
Here you go. Schematic says it should be 12.5 volts. Make sure that connection is rock solid before we seal the panel.
Team Alpha, check the pressure on the forward landing gear.
Looks good from here, boss. All green.
Copy that. We're clear on the intake manifold. Moving to the next bird.
Rotor lock pin is out. Careful with the alignment.
Copy that.
Forward stabilizer cover is clear. Moving to the next blade.
Confirmed.
Let's keep this pace up, team.
Look at the alignment on this access panel. It's slightly off.
I see it. I'll log it for the structural team.
Hydraulics are holding steady, though.
Avionics diagnostic is complete. All parameters are nominal and within spec.
Excellent work. Sign off on the final inspection report and let's get this bird ready for ground tests.
The rust penetration here goes deep, and the damage to the rotor system is critical. I've logged the serial number and the corrosion pattern.
Bad news. The forward transmission casing is completely compromised. It's a total loss.
Copy that. We'll need to bring in the heavy lift gear to swap out this entire section.
Test point 304, confirm voltage.
Reading 12.5 volts, steady.
Copy that, the system check is green.
Careful with the wheels on the left, this cart is loaded down.
Got it. Steady as she goes.
Turn it once more. Where are the jacks? We need them for the next stage.
The powerful hiss of the water jet echoes through the hangar as it strips years of grime from the metal.
The rhythmic splashing of water against the nose cone signals the start of a deep clean.
The sound of scrubbing brushes and the steady flow of water hoses fill the air as the team works in unison.
Engine casing looks solid. Let's get the rotor assembly prepped for inspection. We're on a tight schedule.
The low hum of the hangar provides a somber backdrop to the site of the once mighty machine's decay.
The vastness of the hangar is palpable, a cathedral of engineering waiting for its next mission.
Lowering the bird now. Easy does it. Watch the clearance on the tail. Steady. And touchdown.
Hand me the crimping tool, please. We need to secure this terminal.
Here you go. Make sure the connection is solid before we seal it.
This bundle here is definitely compromised. Look at the fraying on the insulation.
Agreed. I've already applied the yellow tag for replacement. According to the diagram, this bracket needs to be flush.
Got it. Let's run the rivet gun on the lower seam first.
Test point 304, confirm voltage. Reading 12.5 volts, steady. Copy that, system check is green.
Panel secure. Confirmed on the digital manifest.
Good to go.
Avionics check complete. All parameters nominal.
Very good. Sign off on the final inspection.
The landing gear schematic shows a different pressure threshold here.
Cross-reference that with the updated maintenance bulletin.
And make sure the rotor alignment is still within tolerance.
Final check's done. She's ready for the test flight.
Great work, team. Let's get her out to the pad.